Good morning, students. Next topic is enthalpy. What is enthalpy? Enthalpy is the total heat content of a system at constant pressure. Okay. Enthalpy is total heat content of a system at constant pressure. It is denoted by letter H. Denoted by H. It is mathematically expressed as it is the sum of internal energy and pressure volume energy. So, enthalpy is the sum of internal energy E and pressure volume energy. We can express enthalpy like this. This is mathematically expressed enthalpy as the sum of internal energy and pressure volume energy. Now, it is an extensive property. Enthalpy is an extensive property because it depends upon the quantity of the material and also it is a state function. Okay. Next, consider a system changing from initial state to final state. Consider a system changes from initial state to final state. What happens? There will be a change in internal energy and it can be expressed like this, which will be equal to change in internal energy. So, change in enthalpy will be equal to change in internal energy. The reaction, the system changes at constant pressure. So, P remains constant into delta V. There will be a change in volume. So, delta H will be equal to delta E plus P delta V. Delta H represents the heat content. Delta E represents the internal energy of the system. Okay. Now, what happens at constant volume? Constant volume, delta V will be equal to 0. So, P delta V will be 0. So, delta H will be equal to delta E. Also, we can write delta H as QP because it is the heat content at constant pressure. Similarly, delta E will be QV. It is the heat absorbed or evolved at constant volume. So, QP will be equal to QV. Now, in the case of solids and liquids, volume will be negligible. Okay, volume is negligible. So, delta V will be equal to 0. So, delta H will be equal to delta E. So, this equation is insignificant in the case of solids and liquids. So, this equation is significant only in the case of gases. Okay. Next, there is another relation for enthalpy in the case of ideal gases. Consider reaction in the case of ideal gases. In the case of ideal gases, we know the equation PV equal nRT. Okay, consider the reaction of gases taking place at constant pressure and constant temperature. So, P remains constant and T remains constant. So, first state of this initial state of the system, the volume will be V1. So, PV1 is equal to number of moles will be N1 RT. This is first equation. In the final stage, PV2 volume changes. So, N2 RT. By subtracting these two equations, we will get P into V2 minus V1 will be equal to N2 minus N1 into RT, or we can write P delta V will be equal to delta N RT. Okay. Now next what happens? For gases, we know delta H equal delta E plus P delta V, or delta H minus delta E is equal to P delta V. Okay. So, in this equation, we can substitute this. So, delta H minus delta E will be equal to delta nRT. Okay. This is equation 4. Now we know delta H is QP, heat content at constant pressure, and delta is QV, heat content at constant volume, and delta Ng, number of moles of gases, change in number of moles. Okay, so or we can write QP equal to QV plus delta Ng RT. This is a new equation and the relation. Okay.